All right, yesterday we were talking about rectangles and squares. Today we were moving on to parallelograms and triangles, and another kind of parallelogram is a rhombus. So under this umbrella of parallelograms, we also have a rhombus, and that's on these notes as well. Area of a parallelogram. It's the same exactly as the area of a rectangle. The formula is still based on height. You just have to be careful because what do we know about the height? It has to make a 90-degree angle with the base. So when you're looking for your height, you've got to find where the right angle is. That's what you have to find. If you find the right angle, then you know that this is going to be your base, and this is going to be your height. Now in this problem, they didn't give us h. So how could I figure out h? I've got two options. There's two choices. Option number one, use your 30, 60, 90 formulas. Because do you see this little 60 and that 90 right there? That means that that little angle has to be what? Got to be 30, because 30, 60, 90 would add up to 180. Okay, so you could use those formulas. That's one option. Option two, SOHCAHTOA. Option two is SOHCAHTOA because you have a right angle, right triangle. So we have to pick the option that we like the best, because we need to find h. What option do you like the best? Okay, LA likes 30, 60, 90. Anybody else like that, or do you like the SOHCAHTOA? 30, 60, 90. Do you remember the formulas? Hypotenuse equals 2 times the short leg. So could I go from the hypotenuse down to the short leg?
Yes.
What would I have to do to go from hypotenuse 6 down to my short leg? If 2 times the short leg, double the short leg, you get your hypotenuse. How do you go backwards? Divided by 2. So what would my short leg have to be? 3. This one's got to be a 3 right there, because it's half of my hypotenuse, which is a 6. So that would be a 3. That's the first little formula for 30, 60, 90 triangle. The other formula says that the longer leg equals radical 3 times the shorter leg. So whatever your shorter leg is, times it by radical 3 and you'll get the long leg. So now do you see what your height has to be? What is my height going to be? 3 times radical 3. The short leg is 3 times radical 3. Could I make it a decimal if I wanted to? Sure, just do radical 3 in your calculator, times it by 3, and you get a decimal. I'm going to leave it as 3 radical 3 right now. So that way the area here, area would be our base times our height. We now know what the base is. The base is 9, and the height is 3 radical 3. And so your area then is going to be 9 times 3 radical 3, which you could leave as 27 radical 3. Out of curiosity, if we had used SOHCAHTOA, what kind of an answer would we have gotten? Same, but would it have been a radical answer? No, you would have gotten the decimal answer. If we used SOHCAHTOA, which would you have to use? So, ka, or toa? So. It would have been, you're right, it would have been so. Because you would have had the 60-degree angle, opposite is h, and the hypotenuse is 6. O over h would be so, SOH. So you would have set it up, and I'll set it up for you in case you want to remember. It would have been sine of 60 equals the h over 6. And you would have just multiplied by 6 on both sides. And you would have gotten the same answer here as we got here, 3 radical 3. Those two would have been the exact same decimal. So that's your area for that parallelogram. Okay, we good to go? Good to move. I just wanted you to remember SOHCAHTOA, because we will be using that when we get, especially when we get to trig too. So we don't want to forget SOHCAHTOA. Okay, if the area of the following parallelogram is 116, then what is the length of the altitude VW? Okay, and then my question over here, let's answer this one first. it says, why do we use TU as the base and not ST? So right now I'm asking you, why would this be the base and not the bottom one? Why is the 7 not the base? Why is the 14.5 my base? Usually the base is on the bottom, isn't it? Because of the right angle. This right angle right there tells me that I have to have a base and a height. At that right angle has to be your base and your height. So why did we use this one? Because the right angle. The right angle that made from TU to BW. That's why we use that. We get a right angle. Basically, those are the perpendicular sides. So you could put that TU and BW. TU is perpendicular to BW. That's what makes it a base and a height, because they're perpendicular. So let's see if we can solve this H. We're looking for H. They already gave us the area is 116. Tells us that right there in the problem. So we know that our area is our base times our height. That is a formula for this parallelogram. We know the area and we know the base. So we plug those two in. Area is 116, base is 14.5. Just put those two amounts in. And we're trying to solve for H. And if we divide both sides by 14.5, you're going to end up with H is 8. So this height right here came out to be 8. So we don't spend too much time on parallelograms because they're basically the same formula as the rectangle. You need to multiply your base times your height. You just need to make sure you have the right base and the right height, and those two amounts have to be perpendicular to each other. The base and the height have to have that right angle. They have to be perpendicular. All right, so that was example 1 there. Let's go to the triangle. Area of a triangle. What can we make with two congruent triangles? Two congruent triangles. Not necessarily a square. You might if there are two congruent 45, 45, 90. But if you have two congruent triangles, you could actually make what? A parallelogram. Every time. You can make a parallelogram with any two congruent triangles. So you might want to make this triangle in here to show it. That you could make two congruent triangles. If I had another congruent triangle here, I could go like this. I could go like this. And I would have an exact rectangle. Two congruent triangles would also make a rectangle. Now a rectangle is a parallelogram. So any two triangles would make a parallelogram. What is the area for a parallelogram? Base times height, right? So if I want to get the area of this triangle right here, I do my base times my height for my parallelogram, and then what do I do to it? You divide it by 2, because you just want the triangle. You don't want the whole parallelogram. So that's how they got the triangle formula. It's the area is the base times the height divided by 2. Or some people write it as 1/2 times base times height. I like the base times height divided by 2. I think it's a little bit easier to understand. So to find the area of a triangle, we use our base times our height divided by 2, which means that we actually take the area of a parallelogram or rectangle. Area of a parallelogram or rectangle. And divide by 2. Or we just cut it in half. It's half of a parallelogram. You can see that this triangle is half of that parallelogram. It's exactly half of it. This triangle right here is half of this rectangle. So you're going to find that base times height, and then you're going to cut it in half because you only want half of it. You only want the triangle. every single triangle, if you make a duplicate of it, can be made into a parallelogram. Doesn't matter what shape the triangle is, right triangles, obtuse triangles, acute triangles. You put two identical ones together, you could make a parallelogram out of it. So you only want half of the parallelogram to get the area of the triangle. So take what would have been the area of the parallelogram, base times height, and then divide it by 2. So that was the area for a triangle. And now let's try a couple of them. We've got 2 examples on example 2 there. There's 2 things that we have. So what is the area of a right isosceles triangle with a base of 130? So first step, you need to draw the triangle. Now I forgot to put something on this picture. You need to help me out. What else should I add to this picture that would make it more complete? What does it say here? Okay, so I didn't put something on there. What did I not put? Tick mark. Because isosceles, right? Isosceles tells me that this piece right here is equal to that piece right there. Those are equal pieces. It's isosceles. Now the base is 130. So the first step we wanted to do is to draw the triangle. Step 2 is to find our area. To do that, we first need to find the height. That height would be this amount. I'll put it as an H right there. How do I find that height? That's a good question. Do I know anything? Well, I know that this is a 45, 90, because I got the 90 up here, right? And I got the 2 equal sides, so the 2 equal angle. So what does that tell me about this little triangle inside here? You have a 45 in the corner, you have a 90 right here. So what does this angle have to be? Got to be 45. You got 2 little 45, 90s inside of the big 45, 90. So do I know what DB is right here? It's exactly half of the base, which is how much? 65. Do I know if this piece is 65? What does that tell me about this piece? Because I've got 2 45-degree angles right here. So the 2 legs have to equal. So now I just found my height. My height is 65. That's my height. I found the height by using the 45, 90. So my area then is going to be base times height divided by 2. What is my base here? So the base of the triangle, 130, because we're finding the area of the whole triangle. 130 is my base. What's my height? 65 is the height. I don't want just the area of a little triangle. I want the area of the whole one. And then divide by 2. So you get your calculator out. 130 times 65. And then divide it by 2. 8450 and then 4225. So you're going to get 8450 over 2 and 4225 would be your square centimeters. That's the area of the entire right isosceles triangle. Would be 4,225 square centimeters. Okay, if the perimeter of an equilateral triangle is 63, how much is the area? Okay, this is a important problem to figure out. We have some clues here. They gave us the term equilateral triangle. Okay, that means all equal sides. It says the perimeter is 63. So all of these are going to equal, and they're going to all 3 add up to 63. So if I took 63 and divided it by 3, that would tell me the length of each side. What is 63 divided by 3? You get 21. So these all have to be 21s. Does 21 plus 21 plus 21 add up to 63? Yes, so that has to be your side. Now we need to find, so that's our base. We just now found our base. Okay, that's our B. We need the H. What else do we know about an equilateral triangle? If it's got 3 equal sides, then it's got 3 equal angles, and they're all how much? 60. So if they're all equal, they all have to be 60, because 60 plus 60 plus 60 is 180. These two have to be 30s up here, because this one got cut in half when the altitude came down. So we need to find the H. That helps us. We got 2 choices again, just like the very first one we had 2 choices on. You could do your 30, 60, 90 formulas, or you could do right triangle, you could do SOHCAHTOA. This time I'm going to do SOHCAHTOA since I did the other one last time. Okay, so I've got a 60-degree angle. What does the H represent? Opposite. And the 21 is hypotenuse, so I need to use which trig function?
Sine.
Sine, so SOH. So sine of 60 equals the H over 21. Multiply both sides by 21. So in the calculator, I'm gonna put in 60 and find out the sine of 60, 0.866, and then I'm gonna times that by 21. And I get 18.2 as my H. 18.2 is my H. So I'm going to take for my area, my base is 21, my height is 18.2 divided by 2. I found my base and I found my height. And so I just multiply base times height divided by 2. So 21 times the 18.2. 382.2 divided by 2, 191.1. So your area, 191.1. That would just be in square inches. So there's page 1. Those are the parallelograms of triangles. Let's look at the area of a rhombus on the next one. Area of a rhombus. We good on this one?
Yeah.
All right, okay. Let's go to the rhombus. Area of a rhombus. Since a rhombus is a parallelogram, you can use B times H. It works. If you've got the base and the height, then just multiply them together, you got the area. But let's say they didn't give you the base and the height, but they gave you diagonals. You could multiply the 2 diagonals and divide by 2, and you'd still get the area. You'd still get the area. And for some reason I lost this problem, so, oh wait, I didn't. Okay, true or false, a square is a rhombus.
True. False.
A square is a rhombus.
False.
A rhombus has to have 4 equal sides. That's it.
False.
A square doesn't have 4 equal sides.
True.
All it has to have is 4 equal sides. A square is a rhombus. That is very true. Now, a rhombus doesn't have to be a square, but a square does have to be a rhombus. Because all it has to be a rhombus is have 4 equal sides, and a square has that. So a square is a rhombus. A rhombus doesn't necessarily have to be a square, though. Okay, so let's look at this rhombus down here, which is a square. They're using the square this time. And let's see how we would find the area of that square right there. Okay, it's got a diagonal of 4. So we've got 4 equal sides. We know that the area equals side squared, right? That's the formula for a square, but I don't have any sides yet. I do have what, though? I have the hypotenuse. Well, I have a diagonal, don't I? That's a square. So what do you think about if this diagonal is 4, what do you think about this diagonal right here?
4.
It's also 4. And what's one of the formulas that you're allowed to use? Diagonal times diagonal divided by 2. So you can simply take, instead of doing s squared, we're going to get rid of that formula. We're going to use diagonal times diagonal divided by 2 to give me my area. So I'm going to do 4 times 4 and divided by 2. And what's 4 times 4? 16 divided by 2 is 8. 8 square centimeters would be the area. So if you know a diagonal and a square, just do diagonal times diagonal divided by 2. That's why the rhombus formulas are kind of nice. You've got 2 options in a rhombus. 2 options that you could use. Okay, a quick review problem over here. Quick review here. Find the measure of angle ACD. That's this angle right here at X. 2 ways to do it. 2 ways. There's an easy way and a harder way. Easy way would be what? What do I know about this line right here? It makes 180 degrees. What is the 32 and this X? Those are called a linear pair because they're a pair of angles that make a straight line. So X plus 32 has to add up to how much? 180. So you subtract 32, and you're going to get X is 148. So that's the easy way to do it. Now I do want to remind you of an exterior angle theorem. You remember when you add these 2 angles together, it has to add up to the outside angle. Okay, so that's also something that I just want to remind you of. That wouldn't be difficult here because we wouldn't have a number, but we could use that too. That'll still work. We could solve for X that way as well. These X's, this would be a different X right here. This would be a different letter. It would be the 148. All right, so that was just an option, but the way you wanted to do it is that know that 32 and X make a linear pair. So you would use 148 there. Okay, a couple of quick examples here at the end. Find the area of that rhombus. They don't give us, you could find, the lengths of the sides using the distance formula, but I would just, if I was you, I would just find the length of each diagonal. Look at the red line that I just put in there. That length is 8 right here. That's got a length of 8. All the way, if you count straight across, it's 8. That's a horizontal line. And then you put the second diagonal in, and you count that one. That one has a length of 12. All the way down you count, it's going to be 12. So diagonal 1 times diagonal 2 divided by 2 is the formula you could use for that rhombus. 8 times 12 is 96. Divided by 2 and you get 48. So that was the area for the rhombus using the coordinates. We just used the horizontal and vertical coordinates. We counted, got each diagonal, multiplied them together, divided by 2, and that gave us our area for that rhombus. 48 square units that would fit inside there. You get on that one? 48. You just make sure you get both diagonals. 8 is one diagonal, 12 is the other, and multiply them, and then divide by 2. Okay, a couple of practice ones. What should I multiply to get the area of the first one? How would I find the area of that first one? Okay, so my area equals my base times my height. So in this case, the base is 6. The height is where the right angle is, and the right angle is going to where this top part would have been a 6 as well. So 6 times 3, so my area is 18 square centimeters. So that's your first one, definitely 18 square centimeters. Going across. Going across, we have 6 inches, 2 inches, 12 inches. I want to know what you guys would do to get the area of this triangle. You know the formula is base times height over 2. So you think the base is 14? And then your height would be what? Close. You can't have a base that's not part of the triangle. Your base has to be a side in the triangle. So your base has to be what number? 12. Has to be a side. This side of the triangle is your base. Now you can't have a base of a triangle having extra stuff on it where there's no side there. This is your base. This 2 right here is given to you just to try to throw you off and see if you would take the bait. And some of you did take the bait. This is your base. Now if you would have gone straight up 90 degrees, either way you want to do it, you know, straight up 90 degrees, anywhere you wanted to, that's where the 6 would come in. So I could move this dotted line anywhere along here and it would have been 6 going up to the top. So your base is going to be 12 and your height is 6 and divide by 2. So you're going to get 72 divided by 2, which is 36 square inches. So your base has to be a side in the triangle. Your height has to be straight up to the top of that triangle. Okay, what about third one down here? We've got a rectangle on the inside, and we've got 2, looks like 45, 45, 90s, because these 2 are the same, right? So if these 2 are the same, that means these 2 angles are the same. So yeah, they'll both be 45s. The only piece we're missing is this height right here. For this rectangle, 6 times what? We need to know what to get the rectangle's height. Do you remember the 45, 45, 90 formula? Hypotenuse equals radical 2 times just the leg. There is no short or long leg for a 45. They're 2 same legs. So if my legs are both 3, then what would the hypotenuse have to be? 3 radical 2. So to get your rectangle here, you would take 6 times 3 radical 2. So your area is 18 radical 2. Let's get that as a decimal since we're going to want to put them all together. So radical 2 times 18. And you get 25.5, we'll call it, right? So 25.5 is the area for my rectangle. How do I get the area of the 2 triangles? What, in this triangle right here, what's my base and my height?
3.
Is the base 3 and the height 3?
No.
Yes, because there's your right angle. Wherever the right angle is, there's your base and height. So right triangles are nice because you can just multiply the 2 legs and then divide by 2. So 3 times 3 divided by 2, 9 divided by 2 is 4.5. So this one is 4.5. This one is also 4.5. So what's 4.5 twice? 9. You could have just done the 3 times the 3 because there was 2 the same. You didn't have to divide by 2. So 9 plus 25.5, 34.5 square centimeters is what we're looking at for that area right there. That area. The next shape is a trapezoid. You're actually going to learn the formula of the trapezoid tomorrow, but we've already done it once or twice, so you probably remember. But I just want to show you that in this trapezoid, you could make a line right here. And what did I just make? Rectangle and triangle, which we've already learned. So to get the area of this rectangle, it would be 40 times 30, which is 1,200. So there's the area for the rectangle. The triangle would be, my right angle is right here, so it would be the 2 legs. Do I know the top leg? Gotta be 40, because the whole thing is 80 and then half of it was 40. And then this one is gonna be 30. So it's 40 times 30 divided by 2, which is 1,200 divided by 2. So it is 600. So this one is 600. And then when you add those 2 together, you get 1,800 square feet. So you could use when you have a right trapezoid, you could do that plan. You don't have to, because there is a trapezoid formula we're going to see tomorrow. It's actually base plus base times the height, and then divided by 2. Not tomorrow, Thursday. All right, so there's the next one. We got two or three quick ones left. Can I move this? We good? Okay, the next one, we want to find the area of this rhombus. They gave us what? What did they give us right up here at the top? Which is the same as right here at the bottom. It's also 12. That is our base. And here's my right angle, so here's my height. So how do I get the area for that trapezoid? Not trapezoid, sorry, that rhombus. How do I get the area for this rhombus? Is a rhombus a parallelogram? What was the area for the parallelogram? Base times height. So what am I going to do here? Base is 12, height is 8, so 12 times 8. Your area is 96. What about the bottom rhombus? They didn't give us a base and a height, did they? They gave us, what is this called right here? That's a diagonal. So we have one diagonal is 6. What about this second diagonal? The 5 is half, so what's the whole thing? 10. So this whole diagonal right here would be 10. So my first diagonal was 6, my second diagonal was 10, divided by 2. That would be diagonal 1 times diagonal 2 divided by 2. So yeah, 60 over 2 is 30 square meters. Parallelogram. You could graph a parallelogram and find the perimeter. Find the perimeter and area to the nearest 10. So you go over 3 and down 2, make a dot. Over 3 and down 2, over 9 and down 2. So 4, 5, 6, 7, 8, 9 down 2. Okay, we've got over 12, so 10, 11, and 12 up 4. And then over 6 and up 4. There's 3, 4, 5, 6 up 4. So that would be your parallelogram. Okay, so we want to find well, let's first find the area of that. Area of that would be base times whatever the height is right here. Base times height. Do I know the base? My base is 6. My height is, count them, 1, 2, 3, 4, 5, 6. Base is 6, height is 6. What's my area? 6 times 6, which is 36 square units. Now the perimeter would be a little tougher, because you would have a 6 on the bottom, you'd have a 6 on the top, and you'd have to do the distance formula for these two because they're not straight up and down. So you would have to do the distance formula, or you could, well no, that would be you'd need the 2 points and you'd need the big square root formula. X2 minus x1 squared plus y2 minus y1 squared. And you would find this distance, which would be the same as that, and then you would add them together. I'm not going to do that right now for sake of time, but that's what you would do to get the perimeter. You add the 6 plus the 6 plus whatever answer you got here, and the same answer over here, you get your perimeter. Okay, the last one, the altitude of a triangle is twice as long as the base. So your first step is draw a triangle. And draw in an altitude. It says the altitude is twice as long as the base. Where would x and 2x go? Where would my x go? Altitude is twice the base. 2x would go where? Okay, the altitude. So where would x go? The base. The base is x, the altitude is 2x, because its altitude is twice as long. It tells us that the area is 360. So that means that the base times the height divided by 2 equals 360. My base was x. My height is 2x. divided by 2 gives me 360. So what's x times 2x? 2 times x squared, because you got x squared here, x times x. So this would be 2x squared over 2 equals 360. These 2's are going to cancel out. So you're just going to have x squared equals 360. You're going to square root both sides. You're going to get x is approximately 19, because about 19.0, oh no, about 18.97. It rounds up to 19, because 361, the square root of 361 is exactly 19. So you're going to get approximately 19 down here. So what would my altitude have to be if it's twice the base? You solved for x and got 19, so the altitude has to be 38. So that would be your altitude there, 2 times the whatever the base was. All right, there's 8.2.